Hello, this is Mrs. Boots, and this is our lesson on complex numbers. Now, part of this is a review of our simplifying radicals from Algebra 1. We just have one small piece that we're going to add to it. So let's look at our first three examples because those are our review examples. I have 32 under a radical, but 32 is not a perfect square. So I'm going to break it down. Is there a number I can divide 32 by? Well, yeah, 2. So I can rewrite this as the square root of 2 times the square root of 16. Can I take the square root of 2? No. Can I take the square root of 16? Yes. What is the square root of 16? 4. Okay, so this becomes 4 square root of 2. Easy enough. So my goal is to find a perfect square that will divide into that number. 16 is a perfect square. So now let's look at 150. Think about it. 150. I'm thinking $1.50, which is quarters, which is 25 cents. So how many times will 25 go into 150? How many quarters is that? Yep, 6 quarters. So I have the square root of 25 times the square root of 6. Well, the square root of 25, perfect square, is 5. So I have 5 square root of 6. I can't take the square root of 6, and it's a small enough number that I can't break it down anymore. Now, some people learn the factor tree method. That's okay. If that works for you, do it that way. This is a different method. It's called the perfect square method. Okay? 12. But there's a negative out front. That's okay. Just drop the negative down. Negative out front stays out front. No big deal. Okay, 12. What multiplies to give me 12? Well, 2 and 6, but they're not perfect squares. 3 times 4. 3 times 4. So I can write it as square root of 4, square root of 3. What's the square root of 4? 2. So the negative stays out front. I have negative 2, and then I have a square root 3. This is my simplified radical. Cool. Now let's compare example 3 to example 4. What's the same? Well, they both have a 12. And the 12's under the radical. What's different? The negative sign. Notice this negative's under the radical. Now in Algebra 1, they told you this cannot be done. Technically, it still can't be done. But because scientists and mathematicians, we're a little weird. If you have the square root of negative 1, because we don't like that, we're going to assign it a letter. And the letter we're assigning it is I. I means imaginary. Imagine if this were possible. If we didn't have that negative under the radical, imagine what we could do. Okay, so we're splitting that negative out. We're just putting that negative 1 by itself. We just pull it out so that we can imagine what we can do with the rest of it. Well, we already know what we can do with the 12 because we just did it down here in example 3. So do the same thing again. We have a 4, we have a 3. Square root of 4 is 2, square root of 3 is 3. But what happens to that square root negative 1? We substitute. We put an I in its place. Now the I should always go after your leading coefficient, so you treat it like an x or a variable, so it would be 2i square root 3. Okay? Example 5. 1/3 out front, no big deal. We just bring it down. Negative under the radical, split it out. Again, no big deal. We're going to move it aside and we're going to imagine what we could do. What could we do without that negative? It's like life. What could I do if I wasn't so negative? It's great. Okay, 63. What multiplies to give me 63? 9 times 7. It's not a perfect square? Yeah, it's a perfect square. That's awesome. So square root of 9, square root of 7. Marvelous. So I still have the 1/3. Square root of negative 1 becomes an I. Square root of 9 is 3. And square root of 7 is still 7. Now, the 3 and the 1/3. Yeah, we have to multiply them. Simplify. That's okay. right? Because 3 divided by 3 is 1, right? So this becomes I square root 7. Now you can write the 1 in front of it if you really want to. It's not a big deal. Example 6. Got a 5 in front. Okay. Bring it down. That's okay. Negative 1 in a radical, not a problem. There's my negative 1. Now let's imagine what we could happen. If that negative wasn't there, it's just the square root of 121. What multiplies to give me 121? 11 and 11. Very good. So I have the square root. Well, 121 is a perfect square, right? We just said it's 11 and 11. Okay. So this becomes 5. I have an I, and I have 11, because I take the square root of 121. I still have to multiply the 5 and the 11 together. 55. Very good. So 55I. That is my simplified radical for example 6. Example 7. There's 2 negatives. It's okay. What's this negative? It's out front. Write it down. Just drop it down. No big deal. We did that in example 3. If it's out front, you just drop it down. Doesn't matter if it's a number. Doesn't matter if it's a negative. Just drop it down. Okay. Negative under the radical. No big deal. Square root negative 1. Pull it out. Now we're going to imagine what we could do with 96. What can we do with 96? What multiplies to give me 96? Well, I know I can pull 2 out. Let's do this factor tree way, right? So if I pull out a 2, so I would have, let's see, 90 would be 45. 92 would be 46. 94 would be 47. That would be 48. Okay, so I got 2 and 48. All right, so factor tree again. What can we pull out? Well, you're saying 12. Okay, well, let's try 16. All right, 16 times 3. You could have done 12 times 4 and then gone further. I have a perfect square right here. I have my 16, so I'm going to do square root 16. What's left over? 2 and 3. Okay, we'll just write them separate. No big deal. Square root 2, square root 3. Okay, still have the negative in front. Square root of 16 is 4. Square root negative 1 is I. Can I take the square root of 2 and 3? No, so I'm going to multiply those back together. That gives me square root 6. So I have negative 4I square root 6. No biggie. Now number 8. Wow, that looks crazy. No sweat. We're just going to simplify it. What's 7 squared? 49. Okay. What's 3 times 3? 9. What's 49 minus 9? 40. Okay. So this is actually the square root of 40. They just wanted me to simplify it first. So, 40. Just for kicks and giggles, I'll do factor tree. The first ones that come to mind to me are 4 times 10. Those are the easy ones, right? 4 is a perfect square. 10 will split into 5 times 2, but those don't give me perfect squares. So I'm just going to stick with the 10. So I have square root 4 and square root 10. Square root of 4 is 2, and we can't take the square root of 10, so I just have 2 times square root of 10. Now this one didn't have an I in it. And yes, there was a subtraction under the radical. But notice the answer for the subtraction was positive. So let's do our next example. Now let's look at example 9. Okay, they gave us a formula and they gave us the values. Not a big deal. We can plug it in, right? So I have b squared. Well, what's b? b is 3. So that's 3 squared minus 4 times a, which is 1, times c, which is 2. It's okay, we can do a little math. What's 3 squared? Well, that's 9. What's negative 4 times 2? Negative 8. Times 1, technically, still negative 8. 9 minus 8 is 1. What's the square root of 1? It's 1, okay? Not a big deal. But there are students who will put an I there. What does I equal? I, remember, is the square root of -1. Not +1, -1. Okay, so example 10 and 11 are probably looking really familiar to you. Remember, we're going to start with the stuff under the radical. So that -3 out front, we're just going to keep it out front. 2 times 2 on the bottom, that's 4. Now I need to fill in the hole. See my hole? My hole is all that stuff under the radical. So what's under there? So the stuff under the radical is 9 plus, and this becomes 8 times 7. What's 8 times 7? 56. Well, 9 plus 56 is 65. Is 65 a perfect square? No. Now we can leave it like this because we can't break that 65 down. If we really wanted to be ambitious, we could plug it in and approximate it with decimal values. We're not going to do that, okay? Let's look at number 11. -2 in the front, no big deal. I have a square root. I got to fill in the hole underneath. I'm going to do that in a minute. In the bottom, I have 2 times -1, so I also have a -2 there. Now let's fill in the hole. Okay. 2 times 2 squared, that's what? 4. 4, -4, -1 gives me +4, times 15 is 60. So 4 plus 60 is 64. That's a perfect square, right? So I have -2 plus or minus, the square root of 64 is 8. Now for all you people who are looking at your calculator for a plus minus button, it does not exist. It never has. This problem has 2 parts. One part's the positive, so I have to do -2 plus 8, all divided by -2. And then I do -2 minus 8, all divided by -2. -2 plus 8 is 6. 6 divided by -2 is -3. So that is one of the answers, -3. -2 minus 8 is -10. Divided by -2 gives me a +5. So my answers would be -3 and +5. Okay, example 12. The I can be treated just like a variable, sort of. It can be treated like a variable when we add or subtract and when we multiply. When we divide, we have to treat it like a radical. So let's look at some simple problems just so we understand what the I does. So in example 12, what am I doing? Adding, subtracting, multiplying, or dividing? Yeah, we're adding and subtracting. So we treat it like a variable. So the 5 and the -7, they're both constants. So what's 5 minus 7? -2. Okay? Now I do my I's. I have 3I minus 4I. Gives me a -I. This is simplified. I add it together just like variables. So you have your combined like terms. So number 13, I have a quantity, one term, outside a parenthesis. So I'm going to distribute, just like we always do. No big deal. 2 times 3 is 6, with the I attached. Okay. 2 times 5, 10. I times I squared. Okay, that makes sense. Now, here's a trick. I squared, you can substitute a number in for. If I take I and square it, then I'm squaring a square root of -1, which means I get a -1. So I can substitute in a -1 for that I squared. Let's look at that. 6I plus 10 times -1. 10 times -1 is -10. No big deal. I still have my 6I. Now, it is appropriate form to always put the real part or the whole number first and the imaginary part last. That way we can cover it up and say, imagine what I would have if I didn't have all this negative stuff over here. Okay, so I would have my negative 10, but I still have the imaginary part. I just cover it up. Okay? Number 14. Binomial times binomial. So FOIL, right? Double distribute if you had a teacher who called it double distribute. That's okay. It's not a big deal. Okay? 2 times 3, still 6. 2 times negative I, minus 2I. I times 3 plus 3I. I times negative I squared. Now I've got 2 different things that I can do here. Notice I have some common terms that I can combine, and I have an I squared that I can substitute in for. So let's do that. I'm going to have a 6. Negative 2I plus 3I is a positive I. Substitute in a negative 1. So I have a negative of a negative 1. Negative of a negative makes positive. So I'm adding 1. 1 plus 6 is 7. So 7 plus I. Again, the imaginary part goes at the end. Now we're really going to throw you a curveball. Okay, so let's look. I squared is negative 1. Okay. So would you believe me if I said I to the 4th is equal to I squared times I squared? Well, that's negative 1 times negative 1, which is, yeah, positive 1. Okay, so anytime I have an I to the 4th, I can substitute in a positive 1. Okay, but we have an I to the 57. And that just freaks people out. But that's okay. What we're going to do in your calculator, I want you to plug in 57 divided by 4. What does that get us? Well, it gets us 14.25. Okay, so if I converted that to a mixed number, I would have 14 and 1/4. Because that's a quarter, it's a fourth of a dollar, right? So I'm going to rewrite this. This is I to the 4th, so divided by 4, and it goes in an even 14 times. How many i's are left over? 1. So it's going to be times an I on the outside. I to the 4th is equal to positive 1. Okay? So this is equal to 1 to the 14th power times an I. Well, 1 to any power is just 1. So this becomes I. Now, we don't like the I to begin with, but would you rather have I to the 57 or just I? So it's a way to simplify and get rid of things. Okay, let's look at our, what kind of problem is that? Add, subtract, multiply, or divide? It's a divide. The fraction gives it away every time. Anytime you see a fraction, you know you're dividing by something. In this case, we're dividing by 3i. So remember what I said earlier? If it's add, subtract, or multiply, we treat the I like a variable. But if it's divide, we treat it like a radical. So we would have to rationalize the denominator. Remember when you rationalized, you multiply by the radical on top and bottom. Notice I just used the I. I don't need to use the 3, just the I. So on top, now we're multiplying, no big deal. I get a 5i. On the bottom, 3i squared. Ding, 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 ding. Boom. I squared is negative 1. So this becomes 5i divided by negative 3. Okay? Because I is technically a radical, and we don't want radicals in the denominator, we're going to multiply to get it up to the top. It's a fraction. It's division. So do we treat it like a variable or a radical? We treat it like a radical. Do we want it in the bottom? No. Where is it at? In the bottom, of course. So we have to multiply by the conjugate. The what? Conjugate's a fancy word for change it so it's opposite. Okay? So I'm going to write this down. 1 minus 2i. Only I want something to be opposite. Bam. Opposite sign. Notice the minus changes to a plus. Write the exact same thing down in the denominator because you multiply top and bottom by the same thing. Now, if it makes you feel happy, make sure there's parentheses around it because guess what? You have to do a distribute on top and bottom. Top's super easy, right? 3 times 1. 3. 3 times 2. 6. So I have 3 plus 6i. Now we got to do the bottom. Well, because I have a plus minus, I know the middle term is going to cancel. So I'm going to show you a shortcut. You like shortcuts? I love shortcuts. All you have to do is multiply the first 2 together and the last 2 together. So first and last. 1 times 1 is 1. Negative 2, negative 2, negative 4. I times I is I squared. Ding, 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 ding. I squared is negative 1. So let's go ahead and substitute in a negative 1 for that. All right, so what are we going to get? So I still have my 3 plus 6i on top. That's easy. This negative 1 times negative 4 becomes positive 4. So I have 1 plus 4, which is 5. Notice how the denominator now has no i's in it. It went from having i's to having no i's. And the top is what has the complex number with the imaginary part. This concludes all of our notes for the complex numbers lesson.